This is the class lesson for section 2.6 part 1, other types of equations, and we are going to be solving equations with radicals. So let's begin with this first equation, and I have the calculator up because I'm going to show you how to check these solutions. Every solution has to be checked if you raise both sides of an equation to a power. So it's really important that you have a quick way to check these, and I can show you that. Okay, step number 1 is to isolate that radical. So it needs to be alone on one side of the equation when there's just one radical. We're ready now to square both sides to clear that radical. And when you square a square root, you just have what was under the square root, and we have x squared. Now, note we have a squared term and an x term. We have no other choice but to bring everything to the left-hand side and try to factor. So I do want to mention that we'd like to see you do a little bit more algebra in one step, and let me just show you this. On the right side, this was a positive 15, and on the left side of the equation, it's a negative 15. Likewise, it's a negative 2x on the right-hand side, and it's a positive 2x on the left-hand side. So when you move these terms, just change the signs, and you can work quite quickly. So let's go ahead and factor this. This is not a difficult one since the leading coefficient is 1. And now we can use our zero factor property. So x is equal to negative 5, or as x is equal to 3, or both, one or the other. So let's go ahead and put these in our calculator and see if they make the equation true. So let's first go ahead and plug in negative 5. So negative 5, store as x, and press enter. Now every time you press x, negative 5 will show. So your calculator at this point thinks x is negative 5. So now all we have to do is type this original equation and see if putting negative 5 in for x makes it true. So let's go ahead and type that out. X minus the square root of 15 minus 2x. And let's see if putting negative 5 in that makes that true. And we get a negative 10. And so no, this does not make that true. That doesn't really look right. 5, negative, yep, negative 10. Okay, so that is not equal to 0. So we have to throw this solution out. Now, let me show you something cool. Now you can go ahead and, whoops, let's change our x. So we're going to store 3 as x. And now let's go grab this expression, and now plugging in 3, sure enough, it's 0. So plugging in x equal to 3 makes that equation true. So we check these on our calculator. Now you could go ahead and perform the operations plugging these numbers in one at a time, but I thought you might really like this. Okay, now this equation has 2 radicals, and basically you can think of this as working this twice, working 2 problems in one. Okay, so step number 1 is separate those. So we have the square root of 2x plus 3 on one side of the equation, and the square root of x plus 1 positive on this side, plus 1 on this side of the equation. So now we are going to square both sides to clear that radical on the left-hand side. So it's just equal to 2x plus 3. Now the right-hand side, it's a different story. So we have to square this binomial. It's not that difficult, but it just takes a little bit of time. So our f of FOIL is just x plus 1. Both inner and outer are 1 times the square root of x plus 1. So that means I have 2 square roots of x plus 1. And the L of FOIL will just be plus 1, 1 times 1. So it really wasn't too bad. But now I must tell you that we have to isolate this root. So we have some chipping away to do, okay? So let's go ahead, and how about this? I'm going to subtract 2 from both sides of the equation. So now I'm going to have a plus 1. And now I'm going to subtract x from both sides of the equation, and I'll just have 1x left over on the left side of the equation, okay? So now I have just 2 times the square root of x plus 1 left, okay? Now it's time to square both sides, and we need to be careful here, but now I will have x plus 1 all squared. Now each of these gets squared. 2 squared gets squared, and the square root of x plus 1 gets squared. So we end up with x plus 1 squared equals 4 times x plus 1. If you need to pause the video and take a look at that a little closer, you can. So now I'm going to come up here, and I'm going to distribute that 4. So I have x plus 1 squared equals 4x plus 4. And I probably should have written x plus 1 multiplied by x plus 1. Okay, and now I have x squared plus 2x plus 1. Inner and outer are both x, so I have 2x equals 4x plus 4. So we have to bring everything over to the left-hand side. So I'm going to subtract 4x, which will leave a negative 2x over here. And I'm going to subtract 4, which will leave me with a negative 3 on this right-hand side. Again, I have a leading coefficient of 1. I'm in good shape for factoring. So we have an x minus 3 multiplied by an x plus 1 equals 0. So using my 0 factor property, either x minus 3 or x plus 1 equals 0. So x is equal to 3 or x is equal to negative 1. So now let's give these a try in the calculator. We are going into our original equation before we've done any algebra, and we are going to store and work on x equal to 3 first. So 3, store as x, press enter. Now let's put this equation in. So we have the square root of 2x plus 3 come out of that root minus the square root of x plus 1 come out of that, and we want to see if that's equal to 1, and it is. So that is a solution. X equal to 3 is a solution. Now we'll put negative 1 in and store it as x, and we're going to go grab that expression so we don't have to retype it and press enter. And now the calculator just put negative 1 in. And what happened? It's also equal to 1, which is what we were looking for. We wanted that to be equal to 1. So we have 2 good solutions here. Okay, let's go to our last problem, and that's an equation containing cube roots, okay? Let's go ahead and isolate those. So we have the cube root of 4x squared minus 4x plus 1 equals the cube root of x. And you guessed it, if we have a cube root, we will need to cube both sides to clear that. And we end up with 4x squared minus 4x plus 1 equals x. Since I have both x squared and x terms, I have to subtract x from both sides. So I'm going to subtract an x, so I'll have 4x squared minus 5x plus 1 equals 0. So let's see what we have. We have to factor this. I'm just going to go ahead and make this quick little factor here. 4 times 1 is 4, and then I have a negative 5. So we know that that's going to be a negative 4 and a negative 1. They add up to negative 5, and multiplied together they equal 4. So I can rewrite this as 4x squared minus 4x minus 1x. I'm going to keep that 1 in there. Plus 1 equals 0. And as you can see, minus 4x minus 1x is equal to minus 5x. Now we can factor by grouping. I can take a 4x out, and that's an x minus 1. And you know what? I'll take a negative 1 out, and I'll have an x minus 1. So this factored is 4x. Let's go the other way. It's x minus 1 multiplied by 4x minus 1, and that's equal to 0. So x is either equal to 1. How about this? X minus 1 is equal to 0, or 4x minus 1 is equal to 0. X is equal to 1, 4x equal to 1, x is equal to 1/4. So we do need to check these. Let's get started. And let's first go and make sure we can see our original equation. So I want these to equal 0. I'm going to clear my home screen, and I'm going to first store 1 as x. And I'm going to put in the cube root, so that would be cube root of 4x squared minus 4x plus 1. And I'm going to come out of that root minus the cube root of x. And I want this to be equal to 0. And it is. So I have a good solution here, x equal to 1. Now, this is when we're very happy. This is when we have a calculator to check these fractions. So I'm going to put 1/4 in the calculator and store it as my x. I'm going to now go back up and grab this expression and press enter. And what happened when I put 1/4 in the calculator, it also set it was equal to 0, which is exactly what we wanted. We wanted those subtraction of those cube roots to be 0. And that concludes your class lesson on this part.